This is the next video in line for the 1D kinematics. This is all about graphical analysis of motion. In other words, we will specialize in the xt, that's position versus time, vt, velocity versus time, and at, acceleration versus time graphs, where in all three cases, time is on the x-axis. This can be challenging for first-time physics students, not only because people have a hard time reading a graph, but it's linking them up and remembering all the different ways the graphs can change and what they represent. So we'll take a detailed look at all three. For some people, straight memorization is the way for some people to get through this. Other people can really link this to their math, especially for those of you who are right now co-enrolled in calculus. This will really hit home with you guys because we'll actually do this before you learn it in calculus. The first graph we always study is the position versus time graph. Position or displacement is on the y-axis, time is on the x-axis, and the first thing any student needs to be able to do is physically read the graph. So in other words, at 25 seconds, where are you? So you should be able to come out here and do what's called interpolating. Go to the 25, come up, do the best you can to draw a straight line over, and who knows, maybe it's roughly around that number, which looks like it's about a third of the way between 40 and 80. So 1/3 of 40, it would be 40 over 3, so like 13.33333. So maybe at 25 seconds, we're at 53.3333 meter, wherever that is on the number line. The next thing students need to be able to do, besides just reading the graph, is recognizing all the different twists and turns that the lines make. For example, if you have a horizontal line with no slope, your two examples are here, starting from this dashed line, so from roughly 27 seconds on, there is no slope, as well as the instantaneous moment here at 15 seconds, where if I drew a tangent line, there is no slope. That means there's no motion, because time is occurring on the x-axis, but you're not moving up or down on the y-axis, which means you're not changing your position. So time occurs, but you're stationary. There's no motion whatsoever. A linear slope, positive or negative, means you are moving with a constant speed. That means you are not accelerating. And a positive slope means positive direction. Negative slope means negative direction. In other words, so I'm starting here at 0. At the 5-second mark, I now have a straight, or I guess probably 4-second mark, I have a straight linear line that crosses through 5 seconds and goes all the way up to about 7 seconds. So between 4 and 7, I have a no acceleration, constant speed, positive direction, meaning arguably I'm moving to the right because on the coordinate plane going to the right is positive. But coming over here during this segment, I have changed into a negative slope, therefore a negative direction, which means at some point in time you had to have turned around and started moving leftward. And that's where this was. If your slope changes from a positive slope to a negative slope, whether it's a gradual or instantaneous change, like if it was a triangle instead of a parabola, then you've turned around. If you have an exponential line, which is the beginning here, this segment here, as well as this entire part of the parabola, between 10 and 20 seconds, if there's a curve, that means you are accelerating. Your velocity is changing. You can start using some logic. If the line is curving in an upward or in a downward, so exponential growth curve, that means the object is speeding up. Imagine if you had a vertical line, straight vertical line. You would be moving from one spot to another spot without any time occurring. That means you'd be moving so fast you would be teleporting from one spot to another. And no, that's not possible. So the more vertical the line gets, the faster you go. And vice versa, as you start approaching a horizontal line, we're going back to the first bullet, that means there's no motion. So that means this segment for the first 4 seconds, they're exponentially, oops, sorry, didn't mean to go forward. You're exponentially getting faster and faster and faster. But during this segment, you're slowing down because you're turning around. And anytime you turn around, you have to slow down. Then the line starts becoming vertical, but in a downward slope, which means you're speeding up, speeding up. Then we're curving to a flat line, so you're slowing down. And then during this last 3-second segment, you are stationary. It will take practice. This is not something you're going to learn right away, but it is something you're going to be tested on throughout the entire year, including the final exam. So this is a skill you must keep. These graphs will come back again and again. In fact, we're going to add different types of graphs on top of these 3. Your velocity versus time graph, velocity on the y-axis, time is on the x-axis. For the beginning, meaning beginning of the year, you will only have linear lines for these. You shouldn't have exponential, other than a challenge like maybe a bonus question. They are going to show how the speed changes over time. So the one on the left is a constant velocity because the positive value doesn't change, whereas the second one, you have a positive velocity that's increasing over time. It starts at 0, it's getting faster and faster and faster. That means you're accelerating. And remember to link old skills, something we're going to do a lot in this class. To get faster in a positive direction means the acceleration has to point in the same direction as well. So that's also going to be a positive acceleration. Your velocity measured in meters per second is on the y. Time will be on the x. And again, for non-challenge or bonus questions, initially it will all be linear lines. Positive slope, no slope, negative slope. If you have no slope, that means you are moving, because it's a velocity graph, not a position graph. You are moving, but at a constant speed. If you have a slope, positive or negative, that means you are changing your speed. That means during this 4-segment time period, the speed is increasing over time. But during this arguably 8-second time period, from 7 seconds to 15 seconds, the object is slowing down. Now keep in mind, during this segment, this triangular segment, you haven't turned around. It's a positive velocity, still positive, just closer to 0, still positive, closer to 0. That means you are approaching a speed of 0. I have a positive direction that's slowing down. So you can think of 8 seconds to 15 seconds as approaching a stop sign. I'm still moving forward, I'm just slowing down. But now I cross over the x-axis. I go from a positive velocity into the negative quadrant, a negative velocity. If you cross over the x-axis, that means you have changed directions. Now you are starting to go backwards. If there was an exponential line, that means you are changing your speed with a changing acceleration. And we will do those, but not really until later in the first semester. And then we'll definitely see them in the second semester. Same with the last slide. This is not something I'm expecting you to look at the first time and get it right away. You're going to want to do practice problems. You're probably going to want to do outside practice problems in addition to the ones that are assigned to you. You want to take as many online quizzes and watch online videos as well. If you remember from the first set of videos, anytime you see the word instantaneous, that means you're going to be drawing a tangent line on these graphs. And we'll show you how that works here in a little bit. We'll try a matching game, and then we'll do our acceleration graphs. But after this matching, we'll pause the video and we'll start the next video after it. So it doesn't matter which one we do. So we'll take the first one. This is a position versus time graph. It's got a linear line, then it exponentially gets faster and faster and faster. That means this object is going to be getting faster and faster and faster over time. It starts at 0 and moves in a positive direction. That means your velocity is going to start off pretty much at 0, and it's going to get faster and faster and faster and faster. So my guess would be, I will use a pen, I'm just going to underline this one. It's most likely going to be paired with this one. If the velocity is getting faster and faster and faster, that means it has to have an acceleration. It's going to have a positive acceleration, which means I have different options down here, but we'll take B, because right here is the x-axis, so therefore this right here is the positive one. Switch to B, so we'll do a double underline for that one. You're moving in a positive direction, but the position graph is plateauing. If you can remember, a plateau means you're moving at a constant speed of 0. You're slowing down and coming to a stop. That means I need a positive velocity, because I'm moving in a positive direction, that eventually reaches 0. That means it's going to be this one. This positive velocity is slowing down. That means you have to have an acceleration pointing in the opposite direction. The opposite of a positive would be a negative. So if this is my x-axis here, this line is in the negative quadrant, so I will pair that one up with it. I will switch colors. For C, we will underline this one with 1. Positive velocity, or positive movement, starting at a, we'll say maybe like 4, then it's going 5, 6, 7, 8, 9, 10. Once it gets to 10, it starts going back down towards 0, 9, 8, 7, 6, 5, 4. So this object has turned around. If you turn around, that means you have to cross the x-axis. That means it could be this one or this one. If you look at D, we'll double underline it. This one is a gradual change. It's slowing down and then comes back the other way. This would be like throwing an object into the air, slows down and then gains speed. This was an instantaneous change, going in a positive constant, and then bam, like a ball hitting the ceiling, instantly turns around and comes back down. This slope is gradual and constant. This one is moving in one direction and then instantaneously changes downward, which means this one gets paired with that one. And that one will get paired with it. It's got a positive velocity slowing down, therefore it's got to be negative. It's got a negative velocity that's getting faster, it's got to be a negative. So that's this one. So by process of elimination, this one has to go with this one. And it makes sense. You have no acceleration and then one massive change in speed and then no acceleration. So kind of like this one. Even though I said a ball hitting the ceiling, it's probably more a ball hitting a wall, like rolling on the ground. Otherwise, gravity would be accelerating it. If you need to, you can re-watch this. You can go back and look at the other slides, rewind it as many times as you need. But we will pause the video there and then pick up here on the next one.